Welcome, Wildcats. Today we're going to be looking at your actual physical homework assignment for section 1.1, domain, range, and end behavior. So what I'm going to be doing for this section is I'm going to be going through all 15 problems that you have. This will be a long video. Its purpose is not to just watch from beginning to end. Instead, there's going to be timestamps in the description below so that you can see exactly which problems you need help with, and you can go to me solving that exact problem. So the way this is going to work is HRW or HMH, depending upon which way you're launching the program, is going to go through and, like I said, there are 15 problems, but it has multiple different number possibilities for each of those. So what you're going to see is I'm going to do one problem, and your problem may or may not be the exact same. The problem will be the same type of problem, but it may have different numbers. So the steps will be the same, but you may have to change numbers to get your own personal answer. So without further ado, let's take a look at problem 1 for 1.1. It gives us a interval here, a number line, and it asks us to select the interval shown on the number line, and it wants it in inequality, set notation, and interval notation. Well, I see that this is a solid dot, so it does include the 4, and it's everything bigger than 4. So that would be x is greater than or equal to 4. And with set notation, I'm just going to take that inequality and put it right in there, greater than or equal to 4. And interval, we're going to have an open bracket from 4 to infinity. So it looks like they don't actually, oh, the bracket was in the problem itself. So they've got the closed bracket right there and the open parenthesis at the end. So we can check our answer and we are good. So moving on to question number 2. Select the interval 9 to 600 as an inequality and using set notation. So we see here that the 9 is not included, but the 600 is, open parenthesis, close bracket. So for our inequality, it's going to be 9 is less than x is less than or equal to 600. So all numbers between 9 and 600. And once again, for our set notation, we're just going to pull what we have for our inequality straight down into there. Perfect. Moving on to question 3, they've given us a inequality and they want us to turn that into set and interval notation. So once again, we can just take the interval as the inequality as it's written and put it directly into the set notation. So for me, negative 16 is less than or equal to x is less than 3. And for interval notation, this time they don't have the brackets or parentheses out here. So we're going to be looking for one that has negative 16 on the left and 3 on the right, with a closed bracket on the left and an open parenthesis on the right. So that would be this one right here. This one, the bracket and parenthesis are backwards, and this one has brackets on both sides. Straight on to question 4. This time they've given us set notation and they want us to write it as an inequality and as an interval. So to get our inequality, we're just going to get rid of the x such that at the beginning. So we'll just have the inequality portion of this. So we've got negative 3 is less than x is less than 4. Perfect. And for our interval, we're looking for all numbers between negative 3 and 4. And since both of these are just less than signs with no bar under it, we're looking for open parentheses on both. That's closed parentheses on both. That is closed on the left and open on the right. There is our double open parentheses though. Moving on to number 5. So here they're giving us a graph and they want us to find the domain and range of the function. They want us to express it as an inequality in set notation and in interval. So basically we just need to find the domain and range, but we need to find it in all 3 different methods that we've learned how to do it. So in this case, we have the function x squared plus 2. So our domain, how far left do we go? Well, that would be negative infinity to infinity. So negative infinity to positive infinity. Be careful with your selection of less than or greater than. Set notation, we're just going to pull that exact same one in there. In interval notation, the big key for us here is to remember that infinity is always an open parenthesis. Perfect. Now let's look at our range. So it looks like the lowest this graph goes is 2, and the highest it goes is infinity. But it does touch 2, so it's going to include that 2. So we're looking for all numbers greater than 2. Greater than or equal to 2. So here we go. 2 is less than or equal to y is less than infinity. And with set notation, we're just going to pull that same one in there. And then interval notation, we're looking for 2 to infinity. So it's going to be 2 comma infinity. And since we're including the 2, it's going to have the open or the closed bracket on the left. Like so. In behavior, a little bit different. As this moves left, this goes up. So as x approaches negative infinity, y approaches infinity. Sorry, as x approaches negative infinity, f of x approaches infinity. And then as x approaches infinity, f of x is still approaching infinity. Perfect. Looking at number 6. Select the domain and range of the function as an inequality using set notation. So it's the same problem as before, different graph. However, it also does say or complete the explanation why there is no end behavior. So that may be something we see. They're showing here, they're giving us the exponential graph. So our domain, how far left does it go? Never stops. How far right does it go? Never stops. So negative infinity to infinity. Again, be careful with your directions. And it's never equal to when we have infinity. Set notation, we're just going to pull that directly in there. And interval notation, negative infinity, comma infinity. Again, it's not equal to, so make sure we don't have the closed brackets but the open parentheses. So for our range, how far down do we go? Looks like we never cross the x-axis, so it goes from 0, and then it continuously goes up, so it goes to infinity. However, since it never actually touches or crosses the x-axis, the lowest our range can be is 0. So 0 is less than y is less than infinity, but it cannot equal 0. 0 is less than y is less than infinity. Set notation, we just pull the exact same question as the inequality into the y such that. So we have y such that 0 is less than y is less than infinity. And finally, for interval notation, we're looking for 0 to infinity. Again, infinity will always be a parenthesis, never a bracket. And this 0, it does not include it, so that should be an open parenthesis as well. So they've given us a closed bracket on this one, so we know that's wrong. It should be double open. Finally, our end behavior. They're actually going a little backwards here. So we need to be careful and make sure that we're watching the right thing. So this actually, they're starting with as x approaches positive infinity. So as this goes to positive infinity, f of x goes to positive infinity. And as x approaches negative infinity, well, we just said that we're getting closer and closer to 0. Right. First 6 down, now on to number 7. Select the domain and range of the function as an inequality, blah, 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 set notation, interval notation, blah, blah. Once again, exact same question as before, slightly different graph. So, domain, all real numbers. negative infinity to infinity. Oh, except I wasn't paying enough attention. We need to make sure that we don't have the equal signs there. Perfect. Set notation, pull in the same one. Interval notation, negative infinity to infinity. And once again, make sure you're not selecting the one with the closed brackets. Range, negative infinity to infinity. Once again, all real numbers. Once again, making sure that not only do we get the one that doesn't have bars on it, but we need to make sure that we are getting the correct direction as well. Set notation, we just pull the inequality notation into the y such that. So y such that negative infinity is less than y is less than infinity. Interval notation is going to be the same as above. In behavior, this time they are doing the negative infinity first, so as x approaches negative infinity, so as x moves left, y moves down. As x approaches infinity, so as x moves right, f of x moves up. So those three problems were all very similar, slightly different graphs, extra practice for us. Alright, select the domain and range of the function as an inequality using set notation, etc., etc. Once again, exact same problem, just a different graph. This time you'll notice it is a function, but they haven't given us the full equation for it. So for our domain, what's the furthest left we go? I see -5, furthest right, I see 0, I see solid dots on both of those, so -5 to 0, including both of those. So -5 is less than or equal to x is less than or equal to 0. Right there. Set notation, we pull that same thing in. And interval notation, -5, comma 0, with closed brackets on both sides because it includes both of those points. -5 to 0, double closed. Our range, in this case, is the lowest it goes, it looks like, is 0, and the highest it goes is 5, once again including both of those. So 0 is less than 0 is less than y is less than 5. But it's not just less than, it's equal to on both sides. Our set notation, we simply pull the inequalities in again, and our interval notation is 0 to 5, once again, double closed because it does include both sides. In behavior, there is no in behavior because the domain is bounded at -5 at both ends, so x cannot increase or decrease without bound. So we talked about that when we looked at in behavior, but we didn't explicitly say it. So if our x and y's, or if our x doesn't go out to infinity, there is no end behavior. On to number 9. For the given function and domain, select the graph and identify the range using the same notation as the given domain. So we're looking for -x plus 2, so we're looking for a graph that goes downwards, and we can actually plug this into Desmos if we need to. I do have it up on the screen, with domain -10 to 5. Okay? So part 1 out of 2, select the graph. We see that this is double closed, our domain. So since both of these are closed, we know that our dots have to be closed on both sides. This one's open, closed, open, open, closed, open. Looks like this is the only one that's closed on both sides. So that tells us right away, without even looking at the numbers, that it has to be B. But let's double check with the numbers. -10 to 5. But we have -8 and -12. This looks like it's halfway between them, so that would be 10. We've got 4 and 8, halfway between would be 6. But this isn't quite halfway, so it's about half of half, so about 5. Looks correct. and I skipped the rest of that problem. Let's go back. Click next instead of next question. Part 2, identify the range. The range, if we're looking at this, the lowest it goes, it appears to be not quite -4, but it's not halfway, which would be 2. So this looks like -3 to me. And it goes all the way up to 12. So we've got -3 to 12. Again, close dots on both sides, so close brackets on both sides. Check it. There we go. So part 1 check, part 2 check. We are good. Next question. Same thing, different graph. So given function and domain, select the graph and identify the range using the same notation. This is our graph, and they're limiting our domain to x is greater than -8. So since x is greater than -8, we're going to have an open dot. The bottom two are closed, so we know neither of those are correct. And it's got to start at -8. This starts at -8. This starts at -4. So we know it's going to be A. Check. Check. Identify the range. Well, if this is the graph, then this looks like it's going down by 4s again. This appears to be halfway in between. So this is going to be halfway between -8 and -12 would be -10. So -10, and then it's all numbers bigger than that. So -10 is less than y. Again, it's open, so there will be no bracket. So it's going to be all values y such that y is greater than -10. All values y such that y is greater than -10. They gave us the y such that by itself. Part 1 is correct, part 2 is correct. Already done with the first 10 problems. These last 5 problems are all SAT style word problems. It's one of the focuses for Algebra 2 this year is making sure you guys have seen SAT style problems. So let's take a look at some of these. Part 1 out of 2, enter a function that models the given situation. Select the correct domain from the situation. Use set notation for the domain. So, a bicyclist travels at a constant speed of 18 miles per hour for a total of 39 minutes. A function is distance in respect to time equals blank t, where t is the time in hours and d is the distance. So if I'm traveling for 1 hour, I know that if I'm going 18 miles per hour, I should travel 18 miles. So what that tells me is this 18 miles per hour, that's the number that's going to go out in front of our t. So we have the function is 18t, where t is the time in hours, d is the distance in miles. And let's think about a domain. He travels for a total of 39 minutes. T is the time in hours, but 39 minutes is less than an hour, but more than half an hour. So we're going to start at 0, including 0. They are asking for domain, right? Set notation for the domain, yes. So it's more than half, because it's 39 minutes and half an hour would be 30 minutes, but less than 1. So it looks like they're going to tell us that it's 0.65. So we said 0 is less than or equal to t, because when he starts, that's 0 minutes or 0 hours, is less than or equal to 0.65. So 39 minutes is 0.65 hours. If we need to, we can use a calculator to confirm that. But since both of these are 0.65, we know that that's what it has to be. So check. Part 1 is done. Select a graph and the range that matches the function. Use set notation for the range. So in this case, we have, we said up to 0.65. This is 0.6, this is 0.6, this is 0.6, this is 0.6. So it looks like all of these are correct. That means that we have to estimate our total distance in order to figure things out. So for this, we can go ahead and pull up Desmos. We won't need the graphing calculator portion of this, but we just need to know what 0.65 times our 18 is. And Desmos tells us that that's 11.7. So on our MyHRW, he's gone over 12 miles here, so that's too high. He's gone under 12 miles here, so that's about right. And he's gone under 12 miles here, so that's about right. However, when I look at these two graphs, what we see is that this one doesn't start at the origin. So that would mean that at 0 minutes he had already traveled. That doesn't make any sense. We know that at 0 hours he had traveled 0 distance. So this is the one that we're looking for. So our range is all values d, because that's what we're in. We're not talking about y. They said distance traveled is d. So all values d such that d is greater than 0, greater than or equal to 0, and less than or equal to 11.7. Now do keep in mind that if you had just looked at these graphs, the ranges that they pulled up, 11.7 was the only one that you could even see on any of these graphs. So it's the only one that would have made sense. So that is question 11 done. Question 12. Enter a function that models the given situation. Determine a domain from the situation. Use an inequality for the domain. So same question, different situation, and instead of using set notation, they want us to use inequality notation. So an elevator in a tall building starts at a floor of the building that is 105 meters above the ground. So we're starting at 105. The elevator descends 4 meters every 0.5 seconds for 8 seconds. So a function is h of t equals blank minus blank, where t is the time in seconds and h is the height in meters. So where did we start? We started at 105 meters above the ground, and we're going down 4 meters. But we have to be careful because t is the time in seconds, and we're going down 4 meters every half second. So that means we're actually going down 8 meters per second. Little trick question, SAT likes to throw that kind of thing in there. So with that, the domain is going to be from when we start to when we end. We start moving at 0 seconds, and this says that it's going down for a total of 8 seconds. So domain is 0 is less than or equal to t is less than or equal to 8. Right there. And it looks like the second part is going to be the same as well. They want a graph that matches the range, use an inequality for the range. So 8 times 8 is 64. 105 minus 64 is 105 minus 60. 100 minus 60 is 40. So this is going to be 41 is the number that we're looking for. So this goes to 41, this goes to 41, that goes to about 50. This goes to less than 40. So it's one of these two. This one has an open circle though. This one has a closed circle. This one also starts below 100, and we know that we're starting at 105. This one starts above 100. So we actually could have done this with just the starting point. Well, the first half of it we could have. So we would have been able to eliminate this one. So we've got 105 down to 41. So the range is 41 is less than or equal to, in this case, h is less than or equal to 105. Again, if you can't do the math quickly enough in your head, you can always put it into either Desmos or some other calculator. Number 13. Cameron sells tickets at a movie theater. On Friday night, she worked from 6 p.m. to 10 p.m. and sold about 40 tickets every day. That's a lot of tickets. Cameron says that the number of tickets she sold at any time t in hours can be modeled by the function n of t equals 40 times t, where the domain is 0 is less than or equal to t is less than or equal to 1, and the range is 0 is less than or equal to n is less than or equal to 40. Is Cameron's function along with the domain and range correct? So let's think about this. She worked from 6 p.m. to 10 p.m. How many hours is that? That's 4 hours. So that means our domain should be from 0 hours to 4 hours. But she said domain is 0 to 1. That's not quite right. However, this function where she says if she sold 40 tickets every hour, then 40 times the number of hours she worked should be the number of functions, or the number of tickets that she sold. So correct function is 40 times t, so she is correct about the function. The correct domain we just said though was 0 to 4, so she's incorrect about the domain. Again, your numbers may be different. She might have been right about the domain in your question. The correct range, well, when she first starts working, she clearly hasn't sold any tickets. So she says that the range starts at 0. That part's correct. However, she's worked for 4 hours and sold 40 tickets an hour. That means 40 times 4 is 160. So the range should be from 0 to 160. So she's also wrong about the range. Looking at number 14, looks like, yeah, we have a cubic function here. Note that the scale's not the same though. So we've got 1, 2, 3, 4, 5 along the x-axis, and we're going up by 25s along the y-axis. So that might be important for us to know. What are the domain, range, and end behavior of the function? Select the domain and range of the function as an inequality using set notation and using interval. Well, we've actually done several of these problems already, haven't we? Oh, but this is only part 1 of 3. So, domain, inequality. Looks like, yeah, we're going from negative infinity to infinity. And that is an inequality. Set notation, we're going to take our inequality. So we'll have x such that negative infinity is less than x is less than infinity, and interval notation, negative infinity to infinity. Our range, also infinity to infinity. Set notation, we just pull in the same one. Y, all values of y such that y is less than or equal to 1. Novation, interval notation, negative infinity to infinity. Now let's look at the end behavior though. As x goes to negative infinity, y, f of x goes to negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, so once again they reverse them on me. So as x approaches positive infinity, so as x goes to the right, f of x goes up to infinity. So part 1 done. Part 2. How is the range of the function affected if the domain is restricted to negative 3, comma 3? Notice the closed brackets means that it does include them. Select the range of the function as an inequality using set notation and using interval notation. Well, if I restrict my domain negative 3 to 3, you'll notice that I'm doing x to the third, so negative 3 times negative 3 times negative 3, so that's going to be negative 27. 3 times 3 times 3 is positive 27. So my domain is all numbers, so negative 27 is less than or equal to y is less than or equal to 27. Right there. Set notation, pull in the same one, all values y such that negative 27 is less than or equal to y is less than or equal to 27, and interval closed on both ends. Done. Select the graph of the function with the restricted domain. So this only goes to -2. This goes all the way to -5. This goes to -4. This is -3 to 3, so this is the one that we want. All three checked. 15, part 1 of 2. Consider a cable-stayed bridge where the height from the bridge deck to the top of the tower where a particular cable is anchored is about 600 feet, and that the length of that cable is about 800 feet. Select the linear function whose graph models the cable. So we know that we're going to have a negative slope, so the number in front of our x is going to be negative, and we're going to have plus 600 because we're starting at 600. This is the only one with plus 600, so that's the only one that it possibly can be. Check. Identify the domain and range, selecting each as an inequality using set notation. Okay, so domain then would be 0 to, looks like just over 500, maybe 550, 525. Looks like it's 529. Set notation, we're just going to pull that same one in there. Interval notation, 0 to 529. Note the closed brackets. Yeah, this one is the same but open. We see the closed circles, that means it's going to be closed. Range, looks like we're going from 0 to 600. 0 to 600, again, closed dots, equal to. Set notation, pull in the value. And interval notation, again, close dots, close parentheses, or close brackets. Check that one, all done. That's it, guys. That is all 15 problems for 1.1 done and completed with you.